Hello everyone! In this video I am going to tell you about such a dangerous and smelly element as bromine, which is the only element which can exist in a liquid state under normal conditions. In the periodic table of chemical elements, bromine is located in the last but one group of halogens between chlorine and iodine. That's because, from the point of view of its chemical properties, bromine is something between iodine and chlorine. Such properties of bromine led to its discovery in 1825, when two scientists extracted this same element from aqueous solution with the help of chlorine solution, independently of each other. This same experiment can be repeated today. I am using a weak solution of potassium bromide with a small amount of chlorine bleach along with hydrochloric acid. As a result, this reaction produces elementary bromine, which is why the color of the solution changes to pale brown. If to add some toluene or purified petrol, the bromine from the aqueous solution will rise to the top organic layer because such nonpolar solvents as toluene dissolve bromine better than water does. However, when this element was discovered, scientists didn't have pure potassium bromide solution. Back then, the first discoverers of this element used water from local springs rich in bromine ions. 1 liter of this water contains up to 60 mg of bromine. These element's compounds get into water from rocks, where they are easily washed away by streams of water. If water constantly evaporates, concentration of bromide ions will be gradually growing, because of bromine large atomic radius, which doesn't fit with crystalline grids of other minerals, for instance such as sodium chloride. That is why nowadays most of bromine is extracted from salt water in the Dead Sea in Israel or from brines in the deserts of the United States. Just like 200 years ago, today elementary bromine is mostly extracted in laboratories from bromides, for instance from the most widespread bromine-containing salt, potassium bromide. To extract bromine, I poured 50 grams of sodium bromide into a flask. After that, I proceed to make an oxidizer in order to oxidize bromine salt into elementary bromine. I decided to use a mixture of concentrated sulfuric acid and hydrogen peroxide, which is also known as piranha solution. Upon mixing of sulfuric acid with hydrogen peroxide, the liquid heats up. That is why I decided to cool it off in a bowl with ice. After cooling, I poured this extreme mixture into a dropping funnel to better control speed of the reaction. Upon reaction of potassium bromide with a drop of this mixture, the flask fills with bromine vapors, which boil because of the high temperature this reaction produces. Upon adding more liquid, bromine starts volatilizing from the flask, filling the fume hood with smelly vapors. Fortunately, I carried out my experiment using a powerful fume hood, because bromine vapors are very toxic, and if you accidentally breathe in such an orange cloud, you can easily say goodbye to your lungs. Besides, the very name of the element bromine is derived from the Greek word bromos, which means stinky. In reality, bromine smells like something between iodine and chlorine, like chlorine bleach, but it has a sharper smell. After these bromine clouds began forming, I noticed that the mixture in the flask was overheating and most of the freshly extracted bromine volatilizing. In order not to lose this precious non-metal, which I'll need for other experiments, I put the flask into a bowl with icy water and continued adding the oxidizing mixture. In some time, there condensed drops of elementary bromine in the flask, which either floated on the surface of the liquid or sank to the bottom. The whole process of extracting bromine took 15 minutes. After that, I let the mixture cool down more. Since bromine's density is 3 times the density of water, it sank to the bottom. Now, we just need to separate it. The mixture still contained leftover hydrogen peroxide, which is why it formed, releasing toxic bromine vapors. As you figured, under normal conditions, bromine is a liquid. That is why it was very easy to separate it from the leftover reaction mixture, with the help of a syringe. Because of the relatively low boiling temperature of 60 degrees Celsius, liquid bromine quickly evaporates at room temperature, filling the flask with the same orange vapor. To me, bromine vapors looked very much like nitrogen dioxide, a gas which for instance forms when copper reacts with nitric acid. The only difference is the smell. Bromine smell is sharper and stronger. However, I think those who constantly compare smells of toxic chemicals don't live long. As you understood, bromine does not dissolve well in water. Instead, it creates bromine water, which is a mixture of hydrobromic acid and perbromic acid, with elementary bromine leftovers. Such a solution also formed in the leftover reaction mixture. It is prohibited to pour such a mixture into a sink. That is why I decided to neutralize it in a 10% alkaline solution, which is sodium hydroxide. The liquid's yellow color quickly fades away. Let us get back to our freshly extracted liquid bromine. Just as all other halogens, this one is a strong oxidizer. This property of bromine can be demonstrated if we drop a small ball of aluminum foil into a test tube with 1 milliliter of bromine. The reaction starts in a few seconds and is quite active. I have conducted many different experiments with different elements. However, this reaction seems to be the most colorful. When the reaction is over, what's left in the test tube is aluminum bromide, and when water is added to it, it breaks down into aluminum hydroxide and hydrogen bromide, which is breaking out of the test tube in the form of a thick white smoke. However, generally in laboratories, bromine is not used for such colorful reactions. It is most frequently used for organic synthesis. Pure bromine is stored in glass ampoules. It seems to me that this ampoule is twice my age. However, in this form, bromine can be stored practically forever, because in a closed container, it cannot react with anything. Such an ampoule can easily be opened with regular pliers. Later, you can fill a medical syringe with it. As I mentioned before, bromine is frequently used in organic chemistry. One of the most classic experiments with this nonmetal is a reaction between bromine and aniline, which is an oily liquid which smells like burning resin. However, due to the long storage time, some of aniline in the bottle has oxidized into aniline black. That is why we decided to purify aniline by distilling it for the reaction with bromine. Aniline boils at 184 degrees Celsius, and to simplify the distillation process, we assembled a device for vacuum distillation in the laboratory. Liquid there will be flowing under reduced pressure. We decided to heat the contaminated aniline with a heat gun in order for the liquid in the test tube not to boil too much. To make it boil, it's enough to heat it to 86 degrees Celsius, because when pressure is reduced, the boiling temperature of a liquid also reduces. Vapors of the pure aniline began rising up towards the condenser. After condensation, pure colorless liquid aniline ready for the reaction with bromine. I also dissolved aniline in water in order for the reaction to run less turbulently. Upon adding a drop of bromine to the aniline solution, there immediately formed yellowish tribromoaniline sediment in the test tube. If we use more aniline than necessary, the reaction will be too turbulent, heating the mixture to extremely hot temperatures. But not all reactions between bromine and organic chemicals run as smoothly as the reaction between bromine and aniline. For instance, such a substance as benzene doesn't react well with bromine. When benzene and bromine are mixed together, almost nothing happens. Benzene doesn't give its electrons to bromine molecules. To start the reaction, we need a catalyst, which speeds up reactions up several hundred times. Regular iron powder serves as a catalyst in this reaction, and immediately starts reacting with bromine, forming iron-free bromide. This chemical helps bromine molecule rip an electron off carbon atom in the benzene molecule. As a result of this reaction, the mixture quickly heats up and starts boiling, releasing the reaction product, bromobenzene, creating a whole cloud of hydrogen bromide. In order to prove you that this is really hydrogen bromide being released, I am pushing a stick soaked in ammonia solution into the test tube with the reaction mixture. When I do this, there forms white ammonium bromide smoke. The freshly formed bromobenzene contains bromine inclusions. I remove the remaining bromine inclusions with the help of baking soda. As a result, there formed a heavy oily liquid with an intense almond aroma, which is bromobenzene, which can be used for further organic reactions. In the end, I would like to show you a reaction with a bromine compound, potassium bromate. Although this substance is pretty toxic and also cancerogenic, and in some countries, for instance in the United States, it is used as a food additive to improve the texture of dough, for instance when baking bread. If we mix this chemical with sugar and add a drop of concentrated sulfuric acid, the mixture will self-ignite and will be burning with a bright pink and blue flame. Fortunately, its concentration in bread is really low in order for it to self-ignite. However, potassium bromide, which forms later on, isn't good for health either. The thing is, when bromide ions constantly interfere with brain neurons, they tend to slow down nerve impulse transmission, thus causing some psychological disorders, such as psychosis, insomnia, and other mental confusions. Fortunately, in many countries, potassium bromide is not allowed to be used in the food industry. I think today you have learned enough about such an interesting element as bromine. And if you liked this video, don't forget to give it a thumbs up and subscribe to my channel to see many more new and interesting